Okay. Good afternoon to everybody, and thank you for this opportunity to share with you the work that we are doing in the framework of a Latvian Lagoon Refresh project. And my name is Andrea Bonometto, and of course there are a lot of colleagues that are working in the project, both of ISPRA and from the other institute partner of this project. I am the project manager of a Latvian Lagoon project, and the project leader is Rossella Boscolo, also from ISPRA. Just a few words about the ISPRA that probably you don't know. It is the Italian National Institute for Environmental Protection and Research, and work on the very different field of environmental protection, from the water to the air, fresh water, coastal water, all aspects covered by environmental issues, and with the activities that range from research to control, monitoring, and also technical and scientific assistance to the Ministry of the Environment. The headquarters of the institute is in Rome, but there are also two offices close to the Venice Lagoon. One in the city of Venice that work on the monitoring and forecasting of tidal level, and one in Chioggia, that is a small city in the southern part of the Venice Lagoon, that work on the ecological aspect related to transitional water, so monitoring, assessment, and restoration of transitional waters. And the researcher group that is a leader of the Latvian Lagoon Refresh project belongs to the office located in Chioggia, of course. Just few data about the Latvian Lagoon Refresh project. The project started in the 2017 and will end in the August of 2022. So we are in the middle of the project now. ISPRA is the coordinator of the project leader is Rossella Boscolo, and other partners are Veneto Region, the Department for Environmental Protection, that is competent of all hydraulic work in the Venice Lagoon and in the river basin. The Venice Water Authority, that is a office of the Public Works Ministry in Venice, a scientific partner, that is University Ca' Foscari of Venice, and also a small enterprise, the IPROS Environmental Engineer. The project site is located in Venice Lagoon. Probably you already know the Venice Lagoon is a very large lagoon located in the northern part of Adriatic Sea. Is the largest lagoon in Italy, and probably one of the largest in Europe, with 550 square kilometers. The mean depth of the lagoon is 1.5 meters, so it's a very shallow lagoon with a tidal excursion that range between 0.7 to 1 meter. Of course, higher during the storm surge event. Within the Venice Lagoon, there are a lot of different habitats, also of conservation interest related to Nature 2000 habitat. For example, coastal lagoon, intertidal mudflat, but also salt marshes habitat. The project site of Latvian Lagoon Refresh is located in the northern part of Venice Lagoon and cover a surface of 1,900 hectares, more or less. And it is within one of the two sites of community interest that there are in Venice, in the northern site of community interest. And okay, the environmental problem targeted by the project is related to the historical diversion of the river outside the lagoon that occurred from during the last centuries by the Venice Republic. The problem related to the diversion of the rivers outside the lagoon is, of course, an alteration of hydrological processes and patterns with a strong decrease of freshwater input and also of sediment input. At the time, during the last centuries, this work were justified by two main problems. The first was siltation of Venice Lagoon, so with problem for navigation and also for defense of the Venice Lagoon, and also for disease problem from sanitary problem related to the presence of mosquitoes, of course the malaria disease. But now this problem, of course, there is not present problems. So it's time to recover, or at least in part, the natural processes and the natural freshwater input from the river basin into the lagoon. Here, just few examples of the diversion. There was two main rivers flowing into the lagoon in the last centuries. One was the Sila River, and it was diverted in the 1693. This is the Venice Lagoon. Here is the Adriatic Sea. As you can see, here was the original river mouth, and the river was diverted outside the lagoon directly into the sea. And there was another important river, an alpine river, the Brenta, that was diverted outside the lagoon in the southern part of Venice Lagoon, also directly in the sea. Which is the problem? The alteration of hydrological processes and patterns strongly impacted the salinity of Venice, that now is more or less 30 in all parts of the lagoon, also in the inner part of the lagoon. And the lack of fresh water and the lack of sediment impacted the intertidal areas in Venice Lagoon, and salt marshes surface decreased from 170 square kilometers at the beginning of the last centuries to 40 square kilometers up to now. So a very strong decrease of the surface of intertidal areas that in the inner part of Venice of the lagoon, where originally there was a very low salinity, these intertidal areas were covered by reed bed, by Phragmites australis mainly. So the overall strategy of the project is to recover the hydrological processes and patterns as a measure to improve the conservation status of habitat species of conservation interest and also of commercial interest. The main conservation actions were four main conservation actions. The core action is the diversion of a freshwater flow from the Sila River, this is the Sila River, into the lagoon to restore the salinity gradient, the typical salinity gradient of the inner part of the lagoon. Also, another important conservation action is the restoration of intertidal morphology to enhance the development of the reed bed. And last, the planting of Phragmites australis to trigger the colonization of this type of plant. And also, finally, the transplantation of seagrasses, Rūta and Zostrenoltis, as a follow-up of the previous life project that aimed to restoration of seagrasses in Venice Lagoon. The expected result is to recover the salinity gradient in an area of more or less 70 hectares, and in particular to have a salinity lower than 5 in a surface of 5 hectares, lower than 15 in a surface of 25 hectares and lower than 25 in a surface of 70 hectares. And of course, during the preparatory actions, we implemented hydrological and hydrodynamics modeling to forecast the impact of the different solution and to choose the best one. In terms of reed bed restoration, we expect to obtain in the next years reed bed surface of more or less 20 hectares that are 20 increasing from the 30 hectares of reed bed present that are present today in Venice Lagoon to 50 hectares as a total. This is a picture, of course, not in the project site because still there is no reed bed in the project site, but next to another river mouth present in Venice Lagoon. And as you probably know, the reed bed provides several ecosystem services very important for the conservation of coastal habitat, in particular the self-purification capacity of the reed bed of the Phragmites australis. We expect that will help to improve the degree of conservation of habitat coastal lagoon, decreasing the eutrophication, the nutrient amount, the nutrients load, and so the eutrophication problem. And it is also an important habitat for several species, both bird and fish species. So we expect improvement of the conservation of also this type of species. Here there is a short list of species, but I'm not expert in bird species or fish species, but of course, if you have any question about this topic, other colleague of ISPRA and also from University of Venice will answer you, so let me know and I'll check. Okay, this is the list of action, but we directly skip to the first one. So the core action, the diversion of a flow from the Sila River to the lagoon. Here you can see how the river were diverted outside the lagoon. This is the lagoon, and here is the historical maps where you can see the diversion of the Sila River. We are here in this part, and this is the map, the photo of today taken from Google Earth. You can see the historical river mouth, and this is the diversion, and the river is now flowing outside the lagoon, and here is the site, the project site. What we done? The hydraulic works consist of two small channels cutting the floodplain, both on river side and on the lagoon side. Under the higher part of the embankment, there are two pipes, two very big pipes. There are no electromechanical machine, and the flow depends only on the different level between the river and the lagoon. So it's a quite natural flow. There are a real-time monitoring device for the monitoring of the discharge in real time. This is the executive design, and here work in progress last year, and now the work are completed. So from May 2020, the fresh water is flowing again from the Sila River into the lagoon. So it's for Venice is a very important project because it's more or less 20 years that people are discussing and talking about the problem of the increased salinity and the problem of the decrease of reedbed surface, and the idea to to restore a flow from the river into lagoon is a very very long, have a very long time of discussion, and this is the first time that we really we actually done it. So it's a small project because the impacted area is only 70 hectares, but of course it's a important first project that can demonstrate the effectiveness of this type of measures. This is a picture on the riverside. This is the Sila River, and this is the small channel. Here start the two pipes under the embankment, and this is a picture on the lagoon side and the channel lagoon side. Here start the lagoon place. The other, another important conservation action consists on the construction of very narrow morphological features through by the use of biodegradable materials in order to slow down the freshwater dispersion in the lagoon, and therefore to increase the installation, the presence of the salinity gradient. And also this structure a substrate for the reedbed colonization where the depth was not suitable for the reedbed. This is a picture of this type of structure, very narrow, are only 2 meters, and these are located where there are the main gap between natural salt marshes, and this was waves for freshwater dispersion, and so it was a problem because with only 1,000 of liter per second, if the freshwater if there is a too fast dispersion of freshwater, is not sufficient enough to have a significant salinity gradient. So this is the structure, and on this structure in the structure in the next month will be planted reed zones. The reed zones will be also planted in the natural mud flat next to the salt marshes. But okay, some reedbed have been already planted, but we have to wait the next spring, summer to see the first results. We already have some results in terms of salinity gradient, the recovery of salinity gradient. We have two types, two lines of monitoring of salinity. We have both single campaigns to monitor by the probe in several points at a large scale, and next to the input of fresh water, we have 3 probes for the monitoring in real time of the salinity. This is one map. As you can see, the salinity ranges from 25 to 30, but where there is the new input of fresh water, the recovery of freshwater input by the Latvian refresh, already you can see a salinity gradient. The green color is of course the lower salinity, and at the present the discharge is only 300 liter per second, but in the next days and next month the discharge will be up to 1,000 liter per second. So we expect, of course, a higher, a more evident salinity gradient in the future. And this is one example of the data from one of the real-time monitoring by the probe, and you can see that there's a high temporal variability of the salinity due to the flood and ebb phases of the tide. But now from a salinity that was of 30, we have also values lower than 5. So the works is going quite well, and we hope to increase the discharge in the next period. Okay, that's all. The focus of this presentation was on the conservation action, but of course, a lot of time, we spent a lot of time in the preparation actions and also in the monitoring and communication. So if you have any question also on other topics, please